Okay, hey, welcome back. Today I'm going to walk you through some practice problems when it comes to ions and isotopes. Some key things to remember here is that first, in either of these types of elements, the number of protons never change. Our protons will never change, okay? Get that ingrained in your head. So whether it's carbon ions or carbon isotope, whatever that is, whether it's ion or isotope, both of those are going to have the same number of protons as a neutral atom of carbon. The thing that's changing is the number of electrons if it's an ion, or the number of neutrons if it's an isotope. So let's jump into some practice problems on these topics. First, let's start with ions. Remember, cations are positively charged while anions are negatively charged. This means an anion has more electrons than protons, while a cation has more protons than electrons. So let's identify how many protons and electrons are in the following ions. Chlorine 1 minus, calcium plus 2, lithium plus, oxygen minus 2, calcium plus 1, dipositive zinc ion, tri-negative arsenic ion. So let's walk through these. First one, chlorine minus 1. So this chlorine ion has one more negative charge than positive. That's what the minus 1 tells us. Chlorine has 17 protons in its neutral state, okay, because its atomic number is 17, if you don't remember that. Now, since it has a minus 1 overall, that means it has one more electron or negative charge than positive charge. So if we have 17 positive charges, that means we're going to have 18 negative charges. So that's going to say we have 17 protons, 18 electrons. Next one, calcium plus 2. Calcium has a plus 2 charge, meaning it has 2 more protons than electrons. We also know that the number of protons never change, only the electrons do. So calcium's atomic number is 20, that means it has 20 protons. If it has 2 more protons than electrons, the plus 2, then it's going to have 18 electrons. So 20 protons, 18 electrons. Let's go down to lithium plus. Lithium has an atomic number of 3. That means it has 3 protons. The plus 1 overall says it has one more proton than electron, so we have 2 electrons in lithium plus. Now let's go to O minus 2. By oxygen having a negative 2 charge, we know that it has 2 more electrons than protons. Oxygen's atomic number is 8. That means it has 8 protons. Because it has 2 more electrons than protons, the negative 2, that's going to mean it has 10 electrons. Potassium plus 1. Okay, potassium has a plus 1 charge, meaning it has one more proton than electron. It has 19 protons because of its atomic number is 19. That means it has 18 electrons. So what about a dipositive zinc ion? Okay, so dipositive. Let's break this word down. Di means 2, and positive, well, that means positive, like it's positively charged. So it has a plus 2 or a positive 2 charge on zinc. Okay, so dipositive means plus 2. So it's a zinc ion with a plus 2. That means it has 2 more protons than electrons. Well, we know zinc has 30 protons. This means it must have 28 electrons. Finally, we get to our tri-negative arsenic ion. Okay, so just like our last one, we break down our tri-negative. Okay, tri meaning 3 like tricycle, and then negative is our root word. So it's a negative 3 onto our arsenic. So this is arsenic minus 3. Okay, that means it has 3 more electrons than protons. That means if we know that arsenic has 33 protons, and it's a negative 3 charge, so 3 more electrons than protons, that means it has 36 electrons. Now that you have a good feel about the ions, let's look at the isotopes. Isotopes have a varying number of neutrons in the nucleus. That's what changes the weight, because when we're looking at an isotope, the atomic mass is what's changing. When you look at an isotope, we're not talking about changing protons, because protons never change. Instead, in order to change the weight, we're going to have to change the number of neutrons. So let's do some practice problems in identifying the number of neutrons and protons in each of these elements. carbon 13, tin 124, nickel 60, 186W, or 68Zn. Okay, so let's start with carbon 13. 13 is the part of the isotope that indicates a new atomic mass of the isotope, the 13 atomic mass units. We know the number of protons never changes in carbon, and carbon has 6 protons. So all we're going to have to do is take our new atomic mass of 13, subtract our number of protons, which is 6, and that's going to give us our number of neutrons. So 13 minus 6 is 7. So we have 6 protons, 7 neutrons. So let's go on with tin 124. Tin has 50 protons, and we know that never changes. So all we're going to take is our atomic mass, our 124, subtract our number of protons, which is 50, and we're going to find our number of neutrons, which is 74. Okay, let's do nickel 60. We have nickel. We know that nickel has 28 protons. In order to find the number of neutrons, all we have to do is subtract the number of protons from the atomic mass of the isotope. So 60 minus number of protons, which is 28. This gives us 32 neutrons. Now let's work 186W. Well, W is the atomic symbol for tungsten. So this is a tungsten isotope. We know tungsten, if we look at the periodic table, has 74 protons. This 186 is telling us our new atomic mass of the isotope. So all we have to do is take our 186 and subtract 74 from it. This gives us 112 protons. Finally, our last isotope is 68Zn. Okay, Zn is the chemical formula for zinc, or chemical symbol for zinc. We know that zinc has 30 protons, so all we have to do is take our new atomic mass of 68, subtract our number of protons, which is 30, and that's going to give us our 38 neutrons. I hope this helped you out and gave you a better understanding of the basic type of problems you'll see with isotopes and ions. Keep up the good work, and I'll see you next time.